So yeah, that does look confusing. So that would be it. It could have up to 8 and up to 7 turning points, but then when you do it, it doesn't have any.
Nice.
So there's possibly 8, but none of them work.
See, I didn't know how to find how many possibly you could have or the turning points.
I thought that's what you understood. I thought that's the part you understood.
I understood it was finding.
Oh, okay, well that's an easy part to understand. So I think we can get you there pretty quick because that's like just you read it and you know it. So, all right, are we ready to go down to the next ones, or go to the graphy ones? Okay.
The only thing I didn't understand was the multiplicity, that stuff.
Gotcha. That's also easy. So I think we can get you there pretty easily too. All right, so let's see, 32 is there, and then 34, here we go. Let's see, I guess I'll just take a big picture of the whole page and then try zooming. That doesn't work for me. Good try. Don't get sick.
I don't get sick.
Okay, I don't think that's true.
The reason I said it is I haven't been sick in like a year.
Nice.
Which is probably not a good thing. Yes. I wonder if I just like
Why are these crooked?
don't get I'm fine.
Can I make these not crooked? Is that easy to do?
Some small sicknesses over the time.
Yeah. This one. That. But this is the next one that we need to look at, and we got to turn it. Turn. Turn. Save it. Grand. Okay. There's the first parts of, oh, what in the it's right side up on my phone. Let me just like get out of that app real quick and get back into it and see if that fixes it before we try to flip again. It flipped back. What is happening right now? Maybe I'll just retake the picture. I think that's going to be faster at this point than whatever is happening right now. Okay. Right side up, please. Okay. The right side up on the screen? Yes. Okay. Anyway, as I was attempting to say for like an hour and a half now, there's the first parts of 34. And then the zeros. The C part, you might have different numbers if you pick different x's, right? So whatever you picked for x is going to affect what you get for those, and that's going to be true for all of the C parts, right? And then the picture looks like this one. And then 36. There's zeros, there's in behavior, the degree, words, the degree, leading coefficient, and it looks like that.
So when it says to apply the leading term test, it's wanting all of those things?
Yeah, yes. Yeah.
What else that means?
Yeah, I did say that, but
That's okay.
that's been a few days ago, and I only said it once. So, and you didn't pause the video, so. All right.
I did try to look at the video today, but it wasn't out. Was it out?
It was.
Where is it?
Didn't I link it on y'all's page?
Am I just crazy?
I'm pretty sure it's out. I'm pretty sure I did it on Tuesday. I'm
Probably just.
fairly certain I did. It's possible I didn't. It's possible that I uploaded it but did not link it on Classroom, and it's.
What is today, Thursday? Yeah, no.
I think they're all unlisted, so it wouldn't necessarily show up. Doesn't have Thursdays on there?
It has Thursdays, but it should have Tuesdays.
Oh yeah, Tuesdays.
It just has Thursdays.
Oh, it doesn't have. Oh, well then I didn't put it. There you go.
Okay, I'm not crazy. Look at me go.
I think it's on YouTube. I can add it here in just a minute, even, because I believe I've uploaded
I
them
should
all.
have just checked YouTube.
Well, those, because I didn't do thumbnail stuff yet, are unlisted right now, so you wouldn't be able to find it straight through there.
I'd figure it out.
38 looks like that. 40 is, oops, keep going.
I totally missed one of the instructions.
40 is that guy. And then we did 42, right?
Yes.
Okay. 42 looks like that one. All right. So, what questions do we have now? I'd be happy to do 36.
How much time do you need to teach the lesson today?
I need enough.
That's helpful. Is it like a longer lesson?
It's a review. It is something we learned last year. And it's something that you can't just shove it in the graphing calculator and YOLO the answer. So, you know. All right. You said 36?
Yes.
All right. 36. F of x equals 2x times
2x times x plus 5 squared times x minus 3.
Okay. All right. We got to figure out what the leading term is. It is not a 2.
It's, oh, the leading term?
Yeah.
Oh, then it's x plus 5.
No, it's not.
F of x.
So it's an x. He's simplifying it.
No, I'm complicating it
He's complicating.
because we can't figure out what the leading term. Well, actually, you could probably like do it in your head to figure out the leading term if you wanted to, but that would be, you know, a little sketchy perhaps. Now we don't really have to finish this entire process because all we really need is the first one. So all we really care about is because, you know, to actually complicate it the full way, put it into standard form, right? Then we would have to do this entire next distributive property. But all we really care about is the leading term. So all I need to do is go x times 2x cubed, which would give us 2x to the fourth, because that's all we really care about, right?
So you have to solve it. Do you have to solve all of it?
Unsolve it. Yeah, you do. If it gives it to you in a factored form, then you got to undo it.
Okay, how did you get the first step? I understood the second step.
I shortcutted doing this. Remember, there's the shortcut where it's a squared plus 2ab plus b squared. So I went straight to the shortcut.
Got it.
Why is the leading term 2x to the fourth and not 2x to the third?
Because I've got to foil this out.
5 times 5.
This,
25.
this. The first one would be x times this, and 2x cubed times x is 2x to the fourth. Right?
Yes.
Good.
What?
10.
What are you saying?
So x times x is x squared. That makes sense. And then 5 times 5 is 25, so that makes sense. What about that?
And there's 2.
X times 5 is 5x. 5 times x is 5x. 5x plus 5x is 10x.
Where's 25 come from?
5 times 5 is 25.
It's just factoring, dude.
It's just foiling. That's all we're doing, yeah?
Oh my gosh.
But with I just use the shortcut because we're in pre-cal and I like to do that. Clearly I have shot myself in the foot by using the shortcut because as I had to do the long cut twice to get us there, but it's okay. The more I do things, the more we do things, the more we remember things. Sometimes some of us have to do things more times than others. That's how I've been with spelling my whole life.
That's me with everything, including spelling. Except dance.
Except
I'm a
dance.
dancer.
Well, because that's where your brain likes to live. Okay, so the leading coefficient is what?
4.
Leading coefficient is what? 2. The degree is what?
4.
4. What's the end behavior?
It's up and then it's this way.
So the limit as x approaches negative infinity of f of x is what?
Negative infinity, infinity.
And the limit of f of x as x approaches positive infinity is what? Positive infinity. Okay, we did part A. And then part B, it asks for determine the zeros, so we'll go, well, to determine the possible, right? Is that what it says? Oh, it doesn't. That's only on 24 through 32. Okay, so what are the zeros of this function? We have to just roll back the tape to up here where it's already factored for us, right?
So
5 and negative 3.
just 5 and negative 3, right?
0,
0, 5 and negative 3.
because 2x equals 0, divide by 2. Yes? Right? Yes. And then negative 5, multiplicity 2. Yes?
Because of the, yes, I forgot the word for that.
Exponent. And also 3. And then we make us a little T-chart and graph the sucker. So what numbers do we want to pick?
Can we do this just standard maybe?
1? Sure, 1 would be great. And then what were you saying?
Just the negative 2.
We really want ones kind of in each zone, right? Because we want to deal with the zeros. And the more kind of halfway between the zones, the better, generally speaking. If you haven't already shoved this in your graphing calculator, you may want to, because that'll make filling out the chart mucho fastero. So 1 would be in this zone. Negative 6 would be to the left of this one, right? Actually, it wouldn't be in that zone. It would be between these two, right? Negative, what do y'all want? 2, 3, something? Negative 2.5 if we want it perfect. Negative 2 sounds fine. And then something bigger, 4 sound reasonable? Sure, why not? Did you shove it in your calculator already? Oh.
I'm very slowly shoving it in the calculator.
I'm slowly. That's not your calculator, that's Desmos.
This Desmos, man.
Desmos will pull a table up. It does do that.
It won't let me crack it. And it's adding too many parentheses.
What?
There's too many parentheses and it's not cracking.
It's because of where you put the squared.
Whoa.
Nice. X.
Well, I look at this one before I change my witness name. Looks like this.
It's fixing it.
Invalid input.
Yeah, that's what I keep saying.
Okay. This is an example of TI strikes again, having another logic errors, and we need to clear its stupid memory. That would be annoying. Ah, there we go. So I had to put the 2x in parentheses to get it to work, because I guess it thought that we were trying to square this whole thing or something. So I just put the 2x in parentheses and then it fixed it. Okay.
Does this look right? I zoomed it out a lot.
It does look right. Okay, so what's this number? You had it up a minute ago, didn't you?
Then it freaked out.
Oh, they do that sometimes.
Table? What number?
1.
Negative 144.
Negative 144. Okay. Negative 6. 108.
Scroll down.
Negative 2.
180.
180. And 4.
648.
648. I think I'm not going to count by ones. I think that seems reasonable. I think I'm going to count by ones here, but not ones here. 1, 2. And then here, let's count by 50s. Why not? 50, 100, etc. 50, 200, 250. I should have gone smaller because I got to get up to 640, but that's fine.
Just change it to 100.
Change it to,
Down by 100.
oh yeah, I could. Seems reasonable.
Why is it not letting me scroll?
All right, and then zeros at 0 and negative 1, 2, 3, 4, 5. What does the multiplicity of 2 tell us about that 0?
No idea.
That is what multiplicity means, but what does it tell us about, like, what does it do? Yeah, it just kisses it right there. That's right. That's right. So, should have done these in order.
Guessing in this class?
Right? And then right after that, you didn't see it, but right after that, in the challenge, 2 of the contestants were like hardcore making out. It was like, okay, this is the thing that has happened. And then whatever it is, 108, great, still going up this way, and then beep. And then this one is the negative 2, and it's 180, so here-ish, so, and then goes through, and then goes to negative 144, which is about there, and that's so cute. We did it. We can do 28. Is that in the other section? Yeah, that's perfect.
Also one that I would like to do.
Oh yeah, 28's fun.
Yummy.
Is that the one that ends up with like no zeros? Was that the answer? I think so. I think that's what it was.
Comes out with roots and negatives.
Ah. Yeah, let's do it. I like 28. It's a good choice. It looks scary. It's not actually that bad, but it does look scary.
28.
Yeah, 28. You approve of that, Aiden? After we do 28, we better hit lesson 4, 2, 3, whatever we're on. 3, yeah, that's the one. F of x equals x to the 8th or something, right?
4x.
4x to the 8th.
Plus
4x to the 8th.
plus 16x to the 4th plus 12.
Well, luckily for us, this is in quadratic form, so we can, if it's factorable, factor it, right?
Take out a 4.
We could. It has a GCF, so that's probably a great idea. So let's take out a 4 first. X to the 8th plus 4x. Struggling with 4s all of a sudden. I don't know what's happening. To the 4th plus 3. Okay? And now she will factor, right? What's going to go in the first slot?
X4 plus 3, and then X4 plus 1.
Yes.
Oh, because it adds. I got you.
I got you.
Yeah, correct.
So we'd set each factor equal to 0, which we'll walk out on this one because it's got ugliness. Oh, we didn't do the first parts. The first parts are just the reading bits, right? The possible would be 8. It's 8 possible real zeros, right? Because it's the degree. And the turning points, possible turning points, is 1 less than that, so it'd be 7, right?
Oh, I remember that. My brain was just dying.
Your brain just wasn't braining at the moment. Okay, so now back to this, the meat of this. When we move stuff over, we end up with x to the 4th equals -3, and x to the 4th equals -1. Then we take the 4th root of that, and we have problems, right? Equals the 4th root of those things. Does it specifies in the instructions. I want to make sure I'm not lying before I tell you what. So it says determine all of the real zeros. So because we're trying to take for even roots of negatives, there aren't any real zeros. None of them are real. So no real zeros. If the instructions had said list all the zeros, we'd have to list the imaginary ones, but it did not in fact say that.
I understand.
Numbers are non-zero numbers?
What?
What's a real zero?
Well, zeros are the x-intercepts. A real zero would be a number in the real number system. So all of the rational numbers and all of the irrational numbers. Right?
Sure. So it's just.
So not these numbers.
It's the eyes?
Yeah, it's not those. Yeah. 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 Not the complex numbers.
So I thought those numbers are just real compatible.
Yeah, but it doesn't want those. Only the real ones.
Well, that's boring.
So with the multiplicity thing,
Yes, sir.
with the multiplicity thing, like on 36, you just see which one has an exponent, and then that's the multiplicity thing.
Mhm.
Okay. On the parent function you get with the problem, not after you solve it. It's the first
On the
one.
factored one,
Okay,
yeah.
On the fact.
Yeah.
Okay.
Because parent function means something different. But I follow I follow the logical English-tude of your argument. Okay, 2-3, remainder and factor theorem, which is review. Now, will you remember it? I don't know, but no, it's not. But it leads to more precise graphing, so you know. It leads to the problems, those whatever that second set of numbers was, the 30, it leads to you being able to do 34 through 42, but starting with it not factored. and factor theorems. I don't remember whether y'all liked this stuff in Algebra 2 or not. And I have no idea whether Alexa did or not either, because I didn't teach her Algebra 2. She may have loved it. She may have hated it. Most likely, she was totally ambivalent towards it. So, we're going to factor. We're going to jump in straight with an example. Actually, I was going to do that one, but let's do one of the guided practice ones. That way you have the clean example in the book as well as something else. Factor, let's do the ugly one. Factor 6x cubed minus 2x squared minus 16x minus 8 completely using long division.
Oh, no. Yeah, I didn't think I liked this.
If 2x minus 4 is a factor. Okay. So if it's kind of coming back to you, you might sort of kind of remember that where we're going to be headed is they're not even going to give you one of the factors, and you're going to have to just figure it out and guess and YOLO and hope and do a bunch of synthetic division and hope for the best. But you don't know how to do that yet on this. So, and the reason why you don't, this particular problem you could do using synthetic division, but we're going to do long division because there are still some problems, right, that you have to use long division. Like if this had a squared in it, you'd have to use long division. But so we're going to remind you how to do long division. So what we're going to do is we're going to put this guy on the porch and the other guy in the house. Now remember, this one doesn't. But if it's missing a term, so like if this term wasn't there, then you have to add 0 times like x squared and that, like say if this wasn't here and this was the problem, then you would write 6x cubed plus 0x squared and then the rest.
It has to be in the
You have to have all of it in descending order.
I remember this and I slept.
It's not really that bad. Okay. So step 1, after writing the problem, is divide this into that. So 6x cubed divided by 2x is what?
3x.
Squared, yes.
Why is it squared?
Because x cubed divided by x.
Alright, just subtract.
Correct. All correct. Then you distribute this on this whole front bit. So 3x squared times 2x should, if you've done everything correctly, give you this thing. If it doesn't match, you did something wrong. And the next one won't necessarily match. So this one times this will be negative 4 times 3x will be negative 12x squared. And then just like back when we learned long division in little kid class, you subtract, which would be changing both of these signs. So the first one will cancel. If it doesn't, again, you did something wrong. And this next one would be 10x squared. And then what did we do back in the little kid class? We brought the next thing down. Same thing. Bring this one down. Minus 16x. And then 2x goes into 10x squared how many times? 5x times. So plus 5x. Second's up.
What? Okay, never mind.
Why did where did that get changed into positive?
Because you're subtracting it, so since you're subtracting
that's gonna
it,
change
the one
it.
that's
It flips both sides.
Okay.
All that's true. So, yeah, 5x, and then we distribute the 5x. 5x times 2x is 10x squared, which matches, which is good. And then negative 4 times 5x is negative 20x. And then we subtract that one. So this turns into minus, this turns a plus. This cancels. This turns into something else, like 4x. I was going to pause after the full step was done, which is now. But you're always welcome to send up a flare if I go too fast. You can even make a snarky comment about it if you feel like it. That's what they did last year. And we bring down that minus 8. Two x goes into 4x 2 times. And then we distribute. 2 times 2x is 4x. 2 times negative 4 is negative 8. We subtract. And it should all give you, if you do a problem like this correctly, it should give you a remainder of 0, because that's what this being a factor of that means. Is there, you can pull it out with no remainder, right? So now what we have is 2x minus 4 times 3x squared plus 5x plus 2. Right? That's what we have. And so now we have a trinomial that we can factor. That's easy money, right? 2 sets of parentheses. 3x and x.
Positive 1, positive 2.
I was hoping you were going to say that because it's wrong. Because if I do that, we can get a 5, but it breaks at the end, so we got to flip it around.
I had it mixed up.
No, it's good. You played right into my hand. Because now it's plus and plus, and he works. So the completely factored bit would be this. And we are finished, because that's what the problem asks us to do.
So all of these are the factors?
Yes, they are. What? That's wild. It was a lot. Well, just wait. Okay.
Look how beautifully factored that is.
Let's do another division example. One that doesn't come out so pretty. How are we what? What'd you say?
How are we supposed to find the answer when they don't give us the factors?
Well, you do a lot of synthetic division. You've done it, but you don't remember doing it. Well, you might. You may have just blocked it out. Okay, we're going to divide. Let's do that one. Looks cute. Divide 8x cubed minus 18x squared plus 21x minus 20 by 2x minus 3. And we'll do this twice. Get 2 examples in one. Where are we at? 15? We may get there. We'll see. I don't know if we're going to quite finish this lesson. We'll assign part of the homework if not. And then if we don't get through with this lesson, then I will be forced to make at least a partial video for sure. So I will make the time somewhere. All right, so here we go. 2x minus 3 into 8x cubed minus 18x squared plus 21x minus 2. So 2x goes into 8x cubed how many times?
4x squared.
4x squared times. 4x squared times 2x is?
8x cubed.
And then 4x squared times negative 3 is?
Negative 12x cubed.
Squared. That's what I meant. And then we subtract. First one cancels. Next one is negative 6x squared. Bring these one down. Plus 21x. 2x goes into negative 6x squared how many times?
3x.
No. Negative 3x times. Yes, yes, yes. And then the first one is this, because we did it right. The next one, negative 3x times negative 3 is what?
Negative 6.
No, both of them, you did it wrong 2 ways. 3 times 3 is 9, and a negative times a negative is a positive. And then we subtract, plus, minus. First one cancels. We've done beautifully. And then we get 12x over here. And bring these one down.
That's 20, not a 2.
That's a 20.
Yeah, you did say 20, you showed down too.
So the very last one.
I know. I was just trying to decide whether did you already finish it with a 20 in it?
Yeah.
Okay, then I'll put the 20 in. It wouldn't have mattered for the example, but yeah. Okay, 2x goes into 12x how many times?
6.
6 times. And then 6 times that is this, which is great. 6 times negative 3 is negative 18. And then we subtract and get negative 2. So this problem, unlike the last one, does in fact have a remainder. How do we write the remainder? Anybody remember?
Just R. It's like a,
No.
It's like a fraction.
Yeah, we do turn it into a fraction. Turn it into minus 2 over 2x minus 3.
And it's minus because the thing is negative.
Yep. Accurate.
Nice, yummy.
Let's do this one again.
Is that the final answer?
That is the final answer, yes, because this one doesn't ask for the factors. It just asks to divide it. So let's do this one again. So with synthetic division. So, and it's a great one to do with synthetic division because we have to break it first. Because to divide something with synthetic division, this has to be 1. It's not 1. 2 is not 1. Did y'all know that? Facts. So, to divide it with synthetic division, we got to divide everything by 2. And if you remember to do synthetic division, we put this guy in the little box. So it would turn into negative 3 halves, because negative 3 divided by 2, right? But then to divide it, we also have to do one more thing. Do you remember before we put that in the house? He's wrong right now. Because he won't take care of the subtraction the way he is. What do we got to do with him?
Make him positive.
We got to change his sign. We got to flip his sign over.
So that's that's the 2x minus 3 turned into that?
Yes.
Are we getting rid of 2x or just 2?
2. We're getting rid of 2. There's not going to be any letters in synthetic division. Remember, this is the one where you have the number and then all the numbers here. You kind of remember sort of from a ways back. So the first number that would be here is 4, and then negative 9, 21 halves, and negative 1, right?
10. Are we doing 2?
Oh. 10. Yeah. That way we can check ourselves with that. I guess the only.
Oh, this.
Okay, do we remember what to do next?
No.
No.
Yes.
Okay,
Never done synthetic division, have I?
nice.
No, actually.
You're going to do it a lot soon and very soon.
Something about breaking something
We
down.
put this line right there.
Oh,
And then what do we do?
We
Aiden was saying it. What do you do next?
You do something.
The first one just comes straight down,
Yes.
which is what I thought you were saying.
I think that's what I was maybe thinking.
Okay, now what do we do?
New
4 times 3 halves.
4 times 3 halves. What's 4 times 3 halves?
4 and wait.
6, -6.
Positive, because remember this turned to
Oh, yeah,
plus.
positive. The orange is for, it turns into 12 halves.
4 times 3 halves is 6. Now what do we do?
New, add. You
That's a
combine.
good guess, but no. We add these. So -9 plus 6. -3. Look what's happening. Look what's happening. Excitement is happening. Okay, now what do we do?
Now we multiply the -3 times 3 halves.
Yeah, -3 times 3 halves is what?
-4.5.
4.5. I'm gonna leave it as an improper because it's gonna be easier to think about things with my brain. So -9 halves, right? You could write it as a mixed number and be totally fine. Okay, because then you're gonna do 21 halves minus 9 halves.
11 halves.
No.
The 6.
12 halves, which would be 6. Look what's happening. What's 3 halves times 6?
9.
It's 9.
Yummy.
And then
So that gets -1.
it is -1. Why is it different?
Break it.
We broke the system, Sean. Or is it just not?
3 times 3 is in fact 9.
Are you sure you're supposed to turn that 3 halves into a positive?
Yeah. Yeah, because that's the backwards. These all worked. Why is this one different?
Maybe it's not meant to be that accurate.
No, it is meant to be that accurate.
It's math.
Right? Even inaccurate math like statistics is basically how accurate is it?
When you turn the 3 halves positive, are you supposed to turn everything else
No.
opposite as well?
No, see, and that's what these are all matching. So there's some other error. Is it over here? 6 times 3 is 18. This is true.
This word.
Oh, I know what it is. It's fine. It's all fine. It's all good. Give me half a second. Okay, yeah, it's
Supposed to multiply that?
yeah. So now we're at the end. So this would give us 4x. What is 1? It's 1 less than this one. All right, squared minus 3x plus 6 minus 1 over x minus 3 halves.
We know it's
What's the matter? I'm not finished yet, but what's...
the exponent. The exponent is 1 less than the biggest one in the problem.
Yes. Yes. That's this first slot. But this is ugly. And when I multiply the top and bottom by 2, he turns into this one. Right?
How did you know that?
Well, look. I'll show you. We don't want this 2 down here, right? So we can do this.
Back where we started.
Yeah, that's where we want to be.
So this was just a check?
This was to remind you how to do synthetic division and long division. Okay, so then 2 times that is 2, right, Garrett?
Yeah.
I'll just write the end bit. So minus 2. And then 2 times x is 2x. 2 times -3 halves is -3. Blamio. Yeah. Okay. Time is it? Not enough time. So, actually we already did that. So, because I squeezed it in with this one. brilliantly. So the only thing we don't know is the title of the lesson, which is funny. But that's fine. We'll give you a little bit of practice on this for Tuesday. And then we'll do some more homework. I probably, I will either, what I may end up doing is I may end up sticking the remainder and factor theorems from Algebra 2, those 2 videos in there, or I will make a video on just that part of this lesson. And we'll have this whole lesson due on Tuesday. In fact, what I will do, because I can do it right now, is I'll go ahead and put the Algebra 2 ones in now, so you can get to them easier. And then if I make a pre-cal one, I can link that one as well. That sounds fair and reasonable.
Do you want us to do the whole pre-algebra 2, pre-algebra 2, algebra 2 video and make that our notes?
You may.
Okay.
Okay.
I'm still a little confused on how we got the negative 3 over 2. I know we got it from the 2x minus 3.
Okay, so we don't, that can't be, so the reason we had to do it is you're talking about this side, not that side, right? Like how we got it to begin with, right? Okay, so we had to divide everything by 2. Okay, so 2 divided by 2 is 1, so that it fixes the problem, and the negative 3 divided by 2 is negative 3/2. And then to do synthetic division, we have to flip the sign, which is why it's positive. If it would have been positive, then it would have turned negative. So what we're dividing by has to flip the sign on that. And I'm going to stress this right now because when you hit the remainder and factor theorems, trying to find out if something is, you won't flip the sign on the remainder and factor theorems, the remainder theorems as what, on that stuff, because you won't. And so, but if you're dividing this by this using the synthetic division, so like problems, find one where you'd have to do it. Like problem 24, you would have to do that on. Turn by,
in the x on the 2x minus 3.
Oh, this lesson is even easier. Yeah, so I may make you all a video because it will actually not take very long because they're not actually asking you to do anything that's scary. That's the next lesson. Yeah, so I may make you a video so you don't have to watch as long things. Your homework. Homework. Page 115. Numbers 1 through 47. Oh, 47 is every third. And 47. Because 47 is a prime number, so you wouldn't be doing it, and I want you to do 47.
So it's all the multiples of 3?
Yes,
So 1, 3, 9.
etc. All the way to 45, and then also do 47.
1, 3, 6, 9, 12.
Yes. Yeah, because I was going to give you a shortened one again, but because I didn't really think you needed to do 26 problems, but you really need some from all the sections. So every third, we'll fix that.